I'm Clayton Pierce, and this is video experiment number 4 and 5. This is the schematic for the experiment. The parts in this experiment is first we have LED or light emitting diodes, which when they're powered give off light, as is in the name. We have resistors attached to each of these LEDs, which resist the flow of electrons through the wire or thing that it is hooked up to. We have a variable resistor or a potentiometer that gives off a value when turned to different angles on the dial. And we have an RGB LED, which basically is just multiple LEDs encapsulated in one capsule to allow for different colors to be mixed in a way that you'd want. What this experiment does is, depending on the angle of how this potentiometer is turned, a different number will display on this array of LEDs, as there are 13 of them set up in the way that a scoreboard would be at, say, a football game. So if it's turned all the way one way, it'll start with 0, and then as you increase the value of it, it'll go from 0 to 1 to 2 all the way up to 9. Each of the LEDs in this array is hooked up to one of the digital pins and a resistor so that it doesn't get burnt out. These resistors on all of the LEDs are then hooked up to ground, and the potentiometer is powered from the 3.3 volt pin as well as being hooked up to ground through this wire here. The potentiometer's middle pin, the one that reads the values it gives off, is hooked up to one of the analog ports on the board shown by this yellow wire here, and the RGB LED is being used to color code the different numbers, so depending on the number, it gives off a different color, and is hooked up to each of the pins producing color. The first, third, and fourth are hooked up to resistors, and then a wire going to their own unique digital pin, and the second wire is hooked up to ground. In this case, they are on a separate motherboard because the built-in motherboard for this simulator does not have enough digital slots to fit all 13 of these LEDs up here and the RGB LED pins. On the actual build, the RGB LED pins are hooked up into digital inputs on the same board as the LED array, and the numbers don't quite match up for all of these LEDs. This is the experiment number 4 and 5 actually built. As you can see, there is an LED array at the top, potentiometer here, and a RGB LED hidden under there. Sorry for these 3 orange LEDs, they're just the only ones I had to actually be able to build this. What's happening is every single one of these LEDs, as I explained before, has a wire in the positive end right here, jumpered into the digital ports of the board, and then in the negative side has a resistor jumpered to ground. These ones in the middle just have the resistor jumper straight to ground without the need for this little wire. The potentiometer is powered from this 3.3 volt pin here. Jumper with this wire there goes to ground through this wire and then through that into the board, and is read by analog pin 7 with this yellow wire going into the analog pin there. The RGB LED is similar to these ones up top. Each one of the 3 pins for the colors, the red, green, and blue, has its own designated resistor and designated wire color-coded that go into a digital pin, basically acting as 3 separate LEDs like these ones would as they're on their own. Has a ground wire here jumpered with these wires to the ground on the board. These are also connected to this jumper on the bottom, I just didn't mention it before. As you can see, if I turn the potentiometer, it'll go from a 0 to 1 to 2 to 3, 4, 5, 6, 7, 8, and 9, depending on the potentiometer value that is read. Digging deeper into what value makes which number run, I have the serial monitor on screen here, and as you can see, the value changes on the serial monitor depending on which number is being displayed, as it's the potentiometer value defining what number will be displayed, as I will show in the code later. Now we are on to the code section. This is the code for video experiment number 4 and 5. First thing that's happening is we're creating an integer variable for all 13 of the LEDs making up the array on the breadboard. Each LED variable is named L, that LED, so L1, L2, L3 until it gets to 13. And the number on the right here is just letting the code know what port on the mega board the LED wire is plugged into. And similar thing, we're creating integer variables for all of the pins of the RGB LED that color codes our numbers. And again, the numbers on the right just let the code know what port it's plugged into. Here again, we're creating a variable for the potentiometer and letting it know that it's plugged into analog port number 7. In our void setup here, we're setting all of the LEDs I just talked about as outputs to let the code know we want them to light up and output light. Next thing here is just some code to allow the serial monitor to read the potentiometer value as I spin it to helps test what the max value for the potentiometer is, as they're not all what they should be. This one's actually around 700 instead of what I expected it to be at like 1020, give or take. So it's helpful. That's the end of our void setup. In our void loop, first thing that's happening is we're creating a variable, integer variable, that's called pot1 value, that effectively is just a variable to read the value of what our potentiometer is actually giving off so our code can know what it's supposed to run. So it takes the variable that says the potentiometer is hooked in to port number 7, which is variable pot1, analog reads it to find the value, and then makes it a new variable that is the value this gives off. This here is just more code to print the value of the potentiometer to the serial monitor to let me see what the value is reading. And here's the actual code that is running and creating the numbers on our array here. What's happening is I created an if statement that says if the variable I just made, pot value 1, is less than 15 and greater than 70, do this code. This code is function 0, which I'll show at the bottom, and turn on these LED pins. In this case, though, none of them are actually turned on, so the RGB LED is not outputting any colors. I just have it off to color code this number as not having an RGB LED. The code is really repetitive from here. It just changes what RGB pins are on, what function I run, because I have all 10 functions for all 10 numbers from 0 to 9. And it changes the value the code runs at. So it goes from 15 to 70, then 70 to 140, then 140 to 210, and keeps going up in increments of 70 till all the functions have their own designated number slot. And then the RGB LED just turns on different pins to give each number a unique color to color code it. And that happens all the way down to here until we get to number 9 here. Now we have the functions that these if statements run. Basically what's happening is I have a void function called, in this case, 0, that turns on these LEDs 1 to 6, turns off number 7 so it does not glow with this low setting here, and then turns on the rest to make the LED array glow a number 0. This happens all the way down here to the bottom of my code, just turns on and off the LEDs it needs to make the number I want, and then I name it that number, so the function is just called 1, 2, 3, or 4 or whatever. It's very repetitive.